Morning, guys. I was just looking over some questions in the quiz, and thought I would tackle this one. This is a good question in that it's a bad question. It's a tough question. I don't remember how to do it. So I'm just going to use my problem solving skills and see what happens. I'm also making up a different problem, so I can't guarantee that this is going to be a nice answer. So it was something like Ben can do something in 40 minutes. It's like a newspaper route. And then Susan, who's a woman, can do it faster, of course. So how fast could they do it if they're doing it together? Now, first of all, I know the answer should be less than 30 minutes. I also have some kind of expectation that if Ben can do it in the same amount of time, then probably the answer would be around 15 minutes, but maybe a little bit higher because he can't do half the work. So a clever way to think about this would be that if there's, say, 1,200 newspapers to deliver, pick 1,200 because it divides 40 and 30 both divide it. Then basically Ben is doing 1,200 over 40, which is 30 papers a minute, which is astonishing. And Susan's doing 1,200 divided by 30, which is 40 papers per minute. Now I'm wishing I hadn't chosen 1,200. So basically, every minute that they work together, they're doing 70 papers per minute. And given that I had 1,200 there, then really it turns into what's 1,200 divided by 70. That's the number of minutes it's going to take. So it looks like 17.14 is the answer. Now, it has nothing to do with algebra. I'm sure that's not the way that they showed you to solve the problem in the book. Let me show you that that doesn't really matter, that the 1,200 really is irrelevant. And this probably leads to the algebraic solution. I'm going to take, let's see, 1,000. So we got 1,000 divided by 40. That's 25 papers per minute. And then we got 1,000 divided by 30. That's 33.3 papers per minute. And so in essence, they're doing about 58.3 papers per minute. And now I want to find out how long it would take them to do 1,000 papers at 58.3 papers per minute. And so the answer to that is, you will be surprised to find out, 17.15 minutes. Slightly different only because of my rounding here. Okay. So in other words, it really doesn't matter what this top number is. And if we generalize it, we have n divided by 40 plus n divided by 30. And that equals some number, this number, right? And then I was taking that number and dividing n by that. So this is my answer, in other words. So let's think about this, simplifying this expression. This is a little crazy, but n over 40 plus n over 30, again, I like to compartmentalize. This would be, well, I'm going to scale this one up by 30. So n over 40 plus n over 30, 40, 40. So we've got 30n over 1200 plus 40n over 1200. That's equal to 70n over 1200. And then I want to take n divided by 70n over 1200, which is equal to 1200 over 70. These cancel out, and this inverts itself. So basically 127ths is the answer. Which is my 17 point, whatever. So what did I do here to help you? Because this is not your problem. You've got a different problem with different numbers. You know, I mean, I suppose you could memorize some kind of formula like this, and n, since it just crosses out, can just be replaced with 1. So that's like a formula to solve the answer. But I started here with no variables at all. Just kind of thinking about the problem. I did a little bit of kind of guesstimating to think about what's happening with the numbers. I know that's not the normal way to approach these problems in these classes, but I always like to keep thinking about what's the actual purpose of this, because you're never going to solve a problem like this in the real world using algebra or doing anything else. So, you know, what's the point? And the point to me is this sort of habits of thinking and ways of approaching problems. You know, so number one, understanding the problem, making sure that you can kind of visualize or conceptualize what's going on and maybe come up with something that's an approximation of the solution. And then you're thinking about ways to solve. Then you're testing, trying, and then you're evaluating. Now, these two steps in the middle are really vague, and they're not that helpful in terms of a mathematics course or solving any particular problem. In a math class, you're like building your skills to be able to apply different ideas to a particular problem. The more experience you get solving problems, the better you are at it in a given context, right? You know, your ability to solve these math problems is not going to help you solve your leaky faucet. But it could help you kind of think about a structure for solving your leaky faucet. So anyway, I encourage you to explore non-algebraic solutions, even though this is a college algebra class, because often those kinds of things can help. For instance, I think I saw another problem. Ooh, this is a twofer, where it was like, you know, the length is 3 feet more than the width, and the area is, I don't know, 108 square feet. So yeah, you could, you know, come up with symbols and, you know, L equals W plus 3 and L times W equals 108. But you can also just make a table and start brainstorming, right? So here's my width, here's my length, here's my area. So if the length is 3, then if the width is 3 and the length is 3, more than that, that'd be 6. So this would be 18. That's way too small. Okay, what about if this was 10, then this would be 13. This is 130. Okay, that's more like it, but a little too big. What about 9 and 12? Oh, boom, I got my answer. No algebra required. No, that's just an example of kind of attacking the vulnerabilities of a problem. If they're going to give you something that has whole number solutions, this is a really easy way to solve this problem. It doesn't have anything to do with algebra. This is a more formal way to solve the problem, which leads you to a quadratic, which is the whole point of them giving you the problem, because they're like, well, we want you to solve quadratic equations. Well, I also want you to solve quadratic equations, but more importantly, I want you to solve problems. And I'm not stuck on one particular way of doing it as a way of getting there. All right. Merry Christmas, Happy New Year, Happy Hanukkah, Happy Ramadan, and don't say I never gave you anything. All right, talk to you later. Bye.